Welcome to our presentation, Does GPT-3 Grasp Metaphors?, in which we see if we can identify metaphor mappings with generative language models. So first, a quick introduction on what conceptual metaphors are, and they are a cognitive mechanism that is used to transfer physical knowledge structures to abstract domains. And this is an important topic in embodied cognition. And to make it a bit more clear, we have abstract topics, which are the target domains, and they are described using words from a more concrete and physical domain, which is the source domain. And now, to make it even more concrete, here are some examples. First, we have the conceptual metaphor words are weapons, in which we have the source domain of weapons, whose words are used to describe the target domain words. And here are some example sentences. So we have something like, he was bombarded by insults, or your words pierce my heart. Another example is the conceptual metaphor, love is a journey. And here we have the source domain of a journey, whose words are used to describe the topic, the more abstract topic of love. And then we have sentences such as, I don't know where our relationship is heading, or we will go our separate ways now. And this leads us to our research question, can GPT-3 identify the source domain of a conceptual metaphor? So here we have GPT-3, who's given an input sentence, such as, your words pierce my heart, including a target domain for which we want to know the metaphor mapping, in this case words, and then we hope that the model correctly outputs the source domain, such as weapons. So why is it important to analyze conceptual metaphors? Well, metaphors are really everywhere and they reflect how we think about abstract topics. So it's really interesting to see how we do that from a cognitive science and psychological perspectives. And conceptual metaphors can also be used to convey emotions and frame topics in a certain way. So then this can be used, for instance, to analyze political discourse. And generally then, language models, if they are able to identify these metaphor mappings, can help us to automatically conduct such analyses. So here again, the task we are looking at, and now we will focus a bit more on the prompt that is given to the model. So here in general, we first tell the model, extract the conceptual metaphor from the following sentence. Then the sentence such as, this one, you are wasting my time, the target domain that we are interested in, such as time. And then lastly, we ask for the source domain, and this will then be the model completion. We extend the prompt to include few-shot samples. So before we ask for the completion, we will include some samples for which the source domain is already given, so the model can get a better grasp of what it is that we are actually asking for. Now to the dataset that we used. We used 3 different datasets. First, the metaphor list, which is a set of short sentences with a strong focus on the metaphor itself. And it's a collection from Lakoff, who's one of the biggest names in conceptual metaphor theory. And then we have the VU Amsterdam corpus, from which we only extracted non-metaphoric sentences to see how the model deals with sentences that contain no metaphor. And lastly, we have the LCC corpus, which has much longer domain-specific sentences using expert language that are not just focused on the metaphor itself, but have a much larger context around them. And this also has English and Spanish examples. Now to the results. We have an accuracy from GPT-3 of 81% for the simpler metaphor list examples, but we can see that for the longer sentences, more natural sentences, the accuracy drops quite a lot. Regarding the prompting, we can see that the prompt with 12 few-shot samples works best, but on average, 8 few-shot samples in the prompt led to the best results. We then conducted an analysis of how GPT fails, manually creating a taxonomy of different error types and manually analyzing the output then in regards to that taxonomy. Here are some examples. So we have, for instance, this error type of being wrong based on some trigger word in the sentence. So for instance, given the input, the arms race, the model predicted competition is war, which the model most likely does because of the word arms, but this is not the point of the metaphor here. It should have been competition is a race. Then another error class is quite the opposite of this one. It's wrong without any trigger words. So for instance, given the sentence, Sally gave the idea to Sam, the model predicted ideas are children, and there's really nothing about children in the sentence. So it's quite perplexing. Then some other results that are interesting regarding the prompt selection. We have DaVinci 2, which strongly outperforms the next biggest model variant, and also any fine-tuned variant we tried. And we also saw that fine-tuning GPT-3 variants leads to a limited expressiveness in the sense that they generate much fewer source domains. And we also saw that GPT still needs to improve to become useful in this domain, with it being good for short prototypical examples, but not really so great for more natural sentences. And we saw that the model still regularly suffers from specific error types, including hallucinating source domains for which no trigger words are apparent.